Greetings to you guys, welcome to our session. This is a presentation about how to improve the energy efficiency in the 5G networks. My name is Yong Kai Kin. I will first introduce background about 5G network. Nowadays, with the progress of science and technology, the fast development of internet and the changes of society, people rely increasingly on the internet for convenience and fast. For some people, the internet is a place to keep in contact with distant family and friends, getting the new knowledge, shopping, and playing the games. As science and technology changes rapidly, the 5th generation network is the latest innovation. Currently, the image of 5G networks is aiming to extend capacity, better data rate, reduce latency, and increase the quality of service. In the 4G network, it needs 50 milliseconds to connect to the information, but for 5G network, it just costs 1 millisecond. However, the total power consumption of mobile communication network in the global is quite amazing. According to a study from United States, the total power consumption of mobile communication network in the global is 1.5 kilowatt hour meter in a year. It is equivalent to the sum of electricity used between Germany and Japan. The increasingly use of electricity will cause the coal-fired power generation to release a lot of carbon dioxide. It is one of the big goals to mitigate climate change by saving the energy when using mobile communication network. Hence, the topic of our group assignment is how to improve the energy efficiency in 5G networks.
My name is Wei Qiang. So right now I'm going to present the characteristics of how to improve the energy efficiency on 5G. So the first point of this is active and sleep modes. In most wireless networking applications, especially in communications, we want our device to be able to receive some real-time information. But during most times, we don't need the device to work at full load. Therefore, in 5G, they have the function of active and sleep mode. The device only need to transmit little data during sleep mode, but might need to transmit large data during active mode. It could save a lot of energy because if a device works under sleep mode, it will generally use less energy than under active mode. So the second point I'm going to say is schedule management. Schedule management also can save energy because the device does not need to send or listen to the signal continuously even in active mode. They have something called the beacon. Both AP and station only need to send or receive the signal when the beacon turns to their schedule. Thus, it could decrease this actual working time during the active mode. So means it will generally use less energy. The third point I'm going to say is the antenna. From previously 2G, 3G or 4G, we are using isotropic antenna. Isotropic antenna is actually the signal will send equally to all directions. So means it's useful if you use multiple applications, but now we only have used 2 applications for maximum. This kind of transmission will require more transmission power than directional antenna. In 5G, we're using directional antenna, which the signal will be focused in specific direction. We could save about at least half of transmission power than using isotropic antenna. The fourth point I'm going to say is connective radio. From 5G, the future wireless networking, they will combine 5G and connective radio, merging each other to meet the heavy mobile data traffic of future wireless networks. Connective radio is able to sense available wireless channels and decide which channels to use according to programs and configurations. The connective radio can find the spectrums that are less interfered, can also bond several channels together to achieve a high transmission speed. Because the connective use less interfered channels, it could save a lot of power in transmission to attain the same signal-noise ratio. The last point I'm going to say is high transmission speed. When the transmission speed increases, the shorter the end-to-end delay from transferring network data to the payloads. It means the wireless device uses less time to spend on transferring the same payloads. It also means that it uses less energy to transfer the same data because it uses lesser time.
I'm Marcus and I'll be sharing some of the major challenges and requirements that 5G mobile networks need to be able to handle in the future with respect to energy efficiency. These are the 4 challenges that I'll be sharing, which is data traffic volume, number of connected devices, diverse requirements, and energy consumption. Firstly, the data traffic volume. The data traffic volume is expected to experience an exponential growth in the future. This indicates that the per-user data rates and density of mobile networks are expected to increase to the capacity that is more than today. This issue is important from the aspect of green design, as the mobile network evolution should be performed by avoiding the risk of an unreasonable over-provisioning of the network that is, in this case, will become more unsustainable in terms of costs. Next, the number of connected devices. In the coming years, they will be connected to more and various types of machines, such as mobile phones, laptop computers, or tablets. Machines such as smart grid devices, sensors, and surveillance cameras that will be connected to the networks, which is known as machine-to-machine communication. This development will bring new characteristics to the traffic of the network. Therefore, the need of an efficient signaling management is important. Furthermore, the diverse requirements. The 5G evolution will involve many new applications where some requires low latency and high reliability. Therefore, this challenge must be managed or solved because new system requires new and different quality of service requirements. This may significantly affect the green design, as the network power consumption should not have impacts on the correct and efficient management of the quality of service in the system. Finally, the energy consumption. Mobile network infrastructures account for more than 50% of the energy consumption of telecommunication operator networks, while the amount of global energy consumption of ICT approaches 4.5% with a rising trend. It is important that future 5G networks meet the requirements and challenges in energy efficiency manner by achieving 90% of energy efficiency compared to 2010 levels.
I'm Jin Cheng. Now let us talk about the operation on energy-efficient 5G network. First, there is two operations in it, which is SDN and NFV, Software-Defined Network and Network Function Virtualization. Software-Defined Network is a new intelligent architecture for network programmability. The primary idea behind SDN is to move the control plane outside the switches and enable external control of data through a logical software entity called controller. SDN provides simple abstraction to describe the components, the functions they provide, and the protocol to manage the forwarding plan from a remote controller via a secure channel. This abstraction captures the common requirements of forwarding tables for a majority of switches and their flow tables. It is possible to manage the entire network through intelligent orchestration and provisioning system, and it allows on-demand resource allocation, self-service provisioning, truly virtualized networking, and secure cloud service. One of the most interesting complementary technology of SDN, which has the potential to dramatically impact the future 5G networking and how to refactor the architecture of legacy networks, is NFV, Network Functions Virtualization. It refers to the replacement of network function on dedicated appliances such as routers, load balancers, and firewalls. The aim of NFV is to transform the way networks are built and services are delivered. With NFV, we can simplify a wide array of network functions as well as maximize efficiency and introduce new revenue-generating services faster and easier than ever before. NFV is a key enabler of the coming 5G infrastructure. Why? It is helping to virtualize all the various appliances in the network. There is two things we can enable in NFV, which is network slicing and distributed cloud. Network slicing is a virtual network architecture aspect that allows multiple virtual networks to be created atop a shared physical infrastructure. Virtual networks can then be customized to meet the needs of applications, services, devices, customers, or operators. Distributed cloud is helping to create flexible and programmable networks for the needs of tomorrow. Network slicing play a crucial role in 5G networks because of the multitude of use cases and new services 5G will support. A primary 5G NFV network slicing use case will be more powerful mobile broadband with lower latency, but it will also lead to great benefits in bandwidth, mobility resiliency, security, and availability. Future 5G networks will offer operators the flexibility to allocate speed, capacity, and coverage in logical slack according to the demands of each use case. Distributed cloud technology allows multiple data centers to appear as a single virtual data center. In 5G, NFV will be more than merely moving functions to commodity hardware. The 5G NFV distributed cloud computing environment will be scalable, resilient, and fault-tolerant. Combining distributed cloud technology with NFV will allow them to deploy based on performance and other requirements, making it easier for operators to optimize, manage, and maintain networks.
I'm Kai Kin again. Now I will explain the approaches and guidelines. Nowadays, research has drawn more interest on the 5G network because 5G network can achieve substantially higher throughput than 4G. But of course, it consumes more power. In order to increase the energy efficiency of 5G network, researchers have a few solutions to it. I'll be explaining two of the ideas that has the higher potential to improve the energy efficiency on 5G network. For the first technology, massive MIMO and beamforming. MIMO, which stands for multi-input, multi-output. MIMO describes wireless systems that uses two or more transmitters and receivers to send and receive more data at once. Today's 4G base stations have just only 12 ports for antennas to handle all cellular traffic. But for the future 5G base station, we maximize the MIMO by fitting many more antennas on a single array. By doing so, we can implement 100 ports to the 5G base station. This can enable a base station to send and receive signals from many users at once. However, installing so many more antennas to handle cellular traffic also causes more interference if those signals crosses each other. That's why 5G base stations must incorporate the technology of beamforming. Beamforming is a traffic signaling system for cellular base station that identifies the most efficient data delivery route to a particular user, and it reduces the interference and way more efficient for nearby users in the process. By doing so, we need to implement the signal processing algorithm in the massive MIMO base station. This signal processing algorithm plots the best transmission route through the air to each user. Then they can send individual data packets in many different directions, bouncing them off buildings and obstacles in a precisely coordinated pattern. Moreover, when there are no users in a particular area, the traffic signaling system will automatically turn into sleep mode. In a nutshell, the massive MIMO antennas can benefit by radiating less power when transmitting data, making for a more energy efficient system. The utilization of advanced beamforming and massive MIMO schemes also enable focusing most of the transmit energy towards a specific receiver, which in turn decreases the energy being dissipated over an area when there are no users. The second technology, small cells. Nowadays, wireless networks rely on large high-powered cell towers to broadcast their signals over long distances. But we have to know that higher frequency millimeter waves will have a difficult time traveling through obstacles and path loss occurs. When path loss occurs, that means user is experiencing timeout and packet loss. If the network is using selective repeat pipeline protocols, when timeout occurs, sender has timer for each unacknowledged packet, so it has many timers. When this timer expires, it will retransmit only the unacknowledged packet to the user. And what if the network uses go back end pipeline protocols? When timeout occurs, sender has only a single timer for the oldest unacknowledged packet. When timer expires, it will retransmit all sent but unacknowledged packets. If the window size is large, there will be many unacknowledged packets in pipeline. So a single packet loss can cause sender to retransmit many packets again. We cannot overlook the cost and energy consumed by this retransmission process, and we want to have a solution about it for the incoming 5G network. By using the technology called small cells, it not only can overcome this problem, but it can also increase the energy efficiency on 5G network. By doing so, we need to implement thousands of low-power mini base stations or it also can be called small cell base station. These small cell base stations are meant to build closer together than the traditional towers, forming a sort of relay team to transmit signals around the obstacles. This is very useful in cities. For instance, a user moved behind a tree, his smartphone would switch to a new small cell base station automatically to receive signals. And if the user passed through a tall building again, his device would switch again to another new small cell base station automatically in a better range of his device. This can allow the user to receive signals in a continuous manner without having path loss to be occurred. That means the cost and energy consumed by the retransmission process will be eliminated. Moreover, if the device is closer to the small cell base station, it will transmit at lower power levels, which effectively lowers the power out of the cell phone and substantially increases its battery life. In conclusion, the 5G network is best known for its prediction and promise of supporting 1,000 times data traffic as today beyond the year 2020. Although some technologies were already considered, but those technologies have just only tested in labs and are yet to be fully optimized. Researchers are still exploring deeply to improve more on the energy efficiency side for the 5G network without compromising the user experience. If they can solve the remaining challenges and figure out how to make all these systems work together, the exciting and ultra-fast 5G network service could reach consumers in the next 5 years. This is the end of our presentation. Thank you for spending time listening to us. Feel free to drop down any comments below, and until next time, peace.